Hello and welcome to another problem. It is something about trapped air column. I don't know how the air column has been trapped. So let's read the statement of the problem that says 1 meter long thin glass tube open at both ends is is half submerged in air. Okay, this is the initial condition. And then half submerged in water, is half submerged in water, and the upper end of the tube is held with our fingers. Somebody did it. Then we slowly lift it out. So here is we lift it out and turned it over. Fine. And then we turned it over. Okay, the picture is here. How long is the air column? This length, x. Trapped under the water if the external air pressure is 105 kilopascal. Look, initially the air pressure in the tube of length L is equal to external air pressure. That I would like to write P naught. Since the tube is open, and some after you put your finger here, some water is getting some air is getting trapped, but it is still at pressure P naught. The pressure is the same, and then you simply lift it. And I don't know how much water you lifted, but I have taken its length as L1. You just pulled out some length, some water from the tube or something from the container below, and your water is trapped somewhere. Its pressure must have been changed because its volume has been changed and temperature not changed. So we are since the process is completed slowly and carefully, so its temperature is not going to change. So we are willing to use the Boyle's law, famous Boyle's law, PV equals constant, and its pressure will get changed as its volume has changed. And we would like to write the Boyle's law here, and you should write in both the conditions, and this will be P naught L by 2. This is the pressure into volume into area A, that will ultimately get cancelled out, equal to pressure in this water column is P naught, and its length is L minus H1, and the area gets cancelled out. So I would not write in next equation. I will not mention the area thing because it will always get cancelled out. Whenever we write the Boyle's law, they will get cancelled out. And you can see here one more thing. Here, of course, here will be the pressure P naught. Here is the atmosphere outside, so pressure will be here. The pressure will be P naught only, and so the pressure here will be P naught minus rho g H1. So I can write one more equation. This is our equation 1, and the second equation will be P1 equal to P naught minus rho g H1. This will be our second equation. Now we turned the tube, and after turning the tube, the pressure here has been changed. It has become P naught because after rotating, this end will come into the contact of atmosphere, so pressure here will become P naught definitely. So the volume will get changed because pressure change according to the Boyle's law will be followed here. So if pressure changes, volume will get changed, and some volume of water is being trapped here. The length is x. I assume the length is x, and the height of water column is of course h. So we can compare now left and right. extreme left and extreme right condition. The processes are being in succession. So the processes are being performed in succession. So I am going to compare the condition 1 to condition 3, and I would like to write here the Boyle's law first. That will be P naught L by 2, and that will be equal to P2 multiplied by X for this column, this water column. This is something, here is some pressure P2, so I can write it. And one more thing I would like to write, that the pressure here P2 can be P0 plus rho G H1. So I would like to write here P2 equals P0 plus rho G H1. These are 4 equations we got, and we can eliminate P1 from equations, and we will get something like H1 square minus H1 L plus P naught by rho G. You will get yourself plus P naught L by 2 rho G equals 0. And this is a quadratic equation, and after solving, if you want to solve it, you will get a physically meaningful solution as H1 equals 47.6 centimeter. And you can put these results into equation 3 and 4, and you will get X equals P naught L by 2 P naught plus rho G H1. That will give you X equals 47.8 centimeter. Thank you for watching. I was just showing the processes. I was not solving that problem. It's a simple problem. Thank you very much for